Okay, so here we have an algebraic equation that we're solving. Well, they want us to solve for x. So what I'm going to suggest, what I found is nice and helpful, is just to put up a line of where the equal sign is, kind of like to clear in your mind the barrier between the left side and the right side. So there's a left side and a right side there. And this line is straight down the middle, left side, right side. It separates the left side from the right side. And the goal of this problem, what they want from us, is to get x alone at the end, right? That's what it means to solve for x, which is what they're saying. Solve for x, get x alone. So in other words, we want to get rid of the 5, the 6, the other 5, and x can be alone. X is a big loner. He's saying, I want to be alone. Get rid of this 5 and this 6 and this 5 so that I can be alone on my side of the wall. X wants to be alone. So what do we do to get x alone? Well, let's first, there's lots of things you could do. I think it's going to be easiest for us to first deal with the fraction, the denominator. To just get, because fractions are a pain, right? So it's just nice to get rid of those first. So step number one, multiply every term by 6/1. Why 6/1? Because that's the denominator. That's what I want to cancel out. So what will cancel it out is if I multiply by 6/1 here and 6/1 here and 6/1 there. So we've got to multiply every term by 6/1, right? Because you got to do equal treatment. If the left side and the right side are equal and you treat them the same, you do the same thing to all the terms, they're going to be equal on the next line, aren't they? Two things are equal and you treat them the same, they're going to be equal afterwards. That makes sense. It's called the principle of equality. That's what you'll teach younger folks about algebra. Show them it's true. Reason with them logically. They have logic. Show them that the math is just following what's logically, clearly, obviously true. Okay, so now what do we do here? We cancel. 6 and 6 cancel. That's why we did it. We want to get rid of those fractions. So see how that cancels out the 6. Okay, so then what does that leave us? On the next step here, I'll bring it down a little bit. 5x plus, now what happens here? Well, just 5 times 6, 30, equals minus 4 times 6, minus 24. So that was step number 1. Now it's much nicer, no more fractions. Life is always easier in math when there's no fractions. So that got rid of the fractions. That's why we did that first. We multiplied every term by the LCD over 1 is what we really did. The LCD was the least common denominator. It's really the only denominator in this problem, which is 6. Okay, so now step number 2, let's go on with our solving. Step number 2, what are we going to do? We're trying to get x alone. Remember, that's what x is saying. I want to be alone. Get rid of this 5 and this 30 so I can be alone. What's best to do next is to subtract the 30 from both sides. So I'm going to come in here and go minus 30, minus 30. Cancels out. Let's bring down the 5x. This will be minus 54, right? Because it's a loss and a loss. If you lose $24 and lose $30, you know you have a big old loss. You add them up. You just sense the truth of it, right? If you lose 24 and lose 30, you lost 54. Last step to get x alone. Step number 3. We're going to divide, right? Divide by 5, both sides. Boom. X is alone. And there's our answer. Minus 54 over 5. We've got an answer. And so we did it. So what were the steps? First step is to get rid of this denominator. Fractions are a pain. We want them out of there on step 1. So I multiplied through by 6 over 1, 6 over 1, 6 over 1. Cross canceled. Left 5x, no more fraction. Then it just multiplied and multiplied in the other places. And then I just subtracted the 30 divided by the 5. There we go. Got x alone.